Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello, Senior 5 chemistry students. I hope you are all doing well. This is Teacher Pascal, and today we are going ahead with unit number 6, same unit, carbonyl compounds, with the second part of chemical properties of these compounds. When we say the carbonyl compounds, you should always remember that it is the aldehydes and ketones. So we have discussed a number of chemical properties, the reactions of these compounds, like the condensation reactions, you remember that, and the nucleophilic addition reactions. So today we will go on with the same unit, the same chemical properties, but if you remember well, we said that there is a part which is remaining and that will be discussed in the next lesson. So today is the day. And today we will look at the reduction reactions and oxidation reactions. So I want you to remember that, even if it is said it's part 2, we will focus on reduction reactions and oxidation reactions. Of course, because these oxidation reactions are mainly used to distinguish these carbonyl compounds from other organic compounds, we will also look at the different ways of distinguishing carbonyl compounds from other organic compounds. So the objectives of our lessons, at the end of the lesson, you should be able to describe the oxidation and reduction reactions of aldehydes and ketones, the carbonyl compounds, and you should also be able to describe the chemical test of carbonyl compounds. As usual, let us start with a quick revision. And remember, it is always better to find the connection between the revision and the new lesson. So here we have question number 1, name and write a mechanism for the reaction of HCN with ethanol, hydrogen cyanide. Complete the equation below. Propanol reacting with phenylhydrazine. And number 3, how can you synthesize acetone from 2-methylpropane and B, 1-bromobutane from butanol? Let me give you like 2 minutes and you work it out. Hurry up, please. Okay, let's start with number 1. While we will be correcting number 1 or number 2, you can go on and try or think about how we can synthesize acetone from this compound and bromobutane from this compound, 1-bromobutane from this compound. Name and write a mechanism for the reaction of HCN with ethanol. What is the name of that mechanism? Do you remember how we named that mechanism? Or maybe let me show you the reagents we were going to use. We know that Cn can dissociate to give H positive and Cn negative. Do you remember the class of this reagent? This reagent is called a nucleophile, a negative species. And the reaction we will have here, as can be seen from the product we get, it is an addition reaction. So we call the reaction or the mechanism nucleophilic addition mechanism. And remember, we said because this is a weak acid, you can use potassium cyanide or use a base, a strong base, so that the concentration of Cn ions can increase. So we have ethanol, which is CH3COH plus the cyanide ion, and the cyanide ion here will attack the carbon which carries a partial positive charge. Here I have a partial negative charge, and the oxygen carbon double bond will open to produce this CH3CO negative hydrogen and Cn. And in the second step, the intermediate will produce CO negative, H, and Cn will attack HCN, and it takes the hydrogen, while the cyanide ion will take the lone pair, and we produce CH3COH, hydrogen, Cn plus Cn negative. That is the mechanism we call nucleophilic addition. Question number 2, we have been asked to complete that equation. Propanone reacting with phenylhydrazine, it is a condensation reaction. Do you remember what we produce? We produce one product of the combination and another product of the elimination, and the other product is water. So we have CH3, carbon, CH3 with the oxygen atom here, plus H2N, NH with our ring. And here I want to show you, I've written it like this because I want to show you how a water molecule will be removed and we produce CH3, CH3, double bond, N, NH, and this along with a water molecule. So these are the products we get, okay? The products from our condensation reaction. Number 3, how can you synthesize acetone from 2-methylpropane? I hope you are done with this. So let us correct it. We have acetone, which is CH3CO, CH3, and we are about to synthesize it from CH3, CH3, and CH3. What do we have here? We have a compound of 3 carbon atoms, but here we have 4 carbon atoms. So we have to find a way of reducing the number of carbon atoms. One way of reducing the number of carbon atoms is to use the oxidation reaction of alkene, for example, and we break the chain. So in that case, we need to create a double bond in this compound. How do we create the double bond? It's better if we start with halogenation. So with halogenation, we have CH3, CH, CH3, CH3. Let me add chlorine in UV light. And what do we produce? CH3, Cl, CH3, and CH3 plus HCl. And from this compound, we will create a double bond. CH3, CH3, there is chlorine here. We add, let's add sodium hydroxide, and we reflux in ethanol. Remember, when we use ethanol, we get another product, a product of elimination. And we have to reflux. After refluxing, what do we produce? We create a double bond. This is the double bond we produce, plus sodium chloride and H2O. We are almost done. We have the double bond, and we can get propanol if we ozonolize that compound. CH3CH2, CH2 plus O3 in the presence of water. What do we get? We get CH3, COCH3 plus CH2O and H2O2, hydrogen peroxide. And here we have the product we wanted. Okay? We have the product we wanted. And the other one is the preparation of CH3, CH2, CH2, CH2 bromine from butanol. Here, I'm not going to write the answer on the board. But what I'm going to do is to tell you what you can do to transform that compound. Butanol, it has 4 carbon atoms. And the other compound, that bromide we want to produce, it also has 4 carbon atoms. So there is no change in the number of carbon atoms. Now we have to look at how to get that bromine on the first carbon atom. But before that, how do we transform butanol so that we can introduce the bromide atom or the bromine atom in the chain? So we have to reduce it. Reduction of carbonyl compounds. From the reduction, we will get an alcohol. But of course, if you remember butanol has this. Let me write it down, because it is always good to start with the molecule you are working with, you are transforming. So if we reduce this one, we will get the alcohol, but the OH group will be on the second carbon. And we want the bromine atom on the first carbon. So you have to dehydrate the compound and add hydrogen bromide. But remember, because we want to get an anti-Markovnikov product, don't forget to use what? To carry out the reaction in the presence of an organic peroxide, so that you can use the free radicals and produce an anti-Markovnikov product. So I hope you have understood, and you will try that one. Okay? Those different steps are very clear. Now you can try it by yourself. Now let us start the new lesson. We are starting with the use of Brady's reagent to identify carbonyl compounds. So here we are starting the description of how we can distinguish carbonyl compounds from other compounds. When you use Brady's reagent, which is 2,4-dinitrophenohydrazine, from the condensation reaction, you produce characteristic precipitates, yellow or orange precipitates, when you have a carbonyl compound used. But when you use other compounds, you don't get that precipitate. So you can use that reaction to distinguish compounds, organic compounds. Today, the session will not involve practicals. But the next session will be focusing only on the practicals. So what we are explaining, the theory we are explaining now, will be used to carry out the practicals. And that is the reason why I want to invite everyone to be very attentive, take notes, because what we are learning today will be the ones to use in the next session. So if you want to distinguish carbonyl compounds from other organic compounds like alcohols, carboxylic acids, alkanes, alkenes, you use Brady's reagent. When you have a carbonyl compound, you get a yellow or orange precipitate, but for other organic substances, you get nothing, no observable change. It is also possible to use sodium hydrogen sulfide, which reacts with carbonyl compounds to give bright crystals, but the reaction gives no observable change with other organic substances. Reduction reactions. A reduction, what is a reduction reaction? We define a reduction reaction as a reaction in which a decrease in oxidation number is involved. We have studied this in Senior 4. And when, for example, the number of oxygen atoms in a compound decreases, that is also a reduction. If you add hydrogen atoms, it is also a reduction. So in these reduction reactions, we will look at how we can introduce hydrogen atoms in a compound as a reduction, or how we can reduce the oxygen atoms in the compound to get a reduction. So in these compounds, we use lithium aluminum hydride or sodium boron hydride. These are the common reducing agents we use, because remember, these substances, they undergo nucleophilic reactions. They are easily attacked by nucleophiles. So we can only use these, or we can use these reducing agents because they provide a hydride ion, the nucleophile. So the hydride ion which is provided will reduce the carbonyl group to an OH group. What do we get? If, for example, you take CH3CO and CH3 and treat it with lithium aluminum hydride in dry ether, what do we get? We get CH3CH, CH3 and OH. We have introduced a hydroxyl group. And you can see, as I said, we have introduced 2 hydrogen atoms. The addition of hydrogen atoms in a compound is called a reduction. What do we get when we use a primary, when we use an aldehyde? Sodium boron hydride in dry ether. What do we get? Dry ether. We produce CH3, CH2, OH. So when you reduce ketones, you produce secondary alcohols, and when you reduce aldehydes, you produce primary alcohols. There is no carbonyl compound you can reduce to get a tertiary alcohol. Okay. Here we have another way we can use to reduce these compounds, but which requires a bit high temperature and high pressure. We can also use hydrogen and platinum. If you use hydrogen in platinum as a catalyst, you also produce an alcohol. You can also use nickel as a catalyst. We can also reduce these compounds to a methylene group. A methylene group is this one, this CH2 group. So it is possible to remove the oxygen and you produce a CH2 group. And here we use several methods, but the common one is to use, or the one that was first discovered was to reflux the aldehyde or the ketone with amalgamated zinc. And this is zinc with a surface layer of mercury in concentrated HCl. So if you take a substance like CH3COCH3 and you use zinc coated with mercury, what do we produce? We produce CH3, CH2, CH3. Most commonly, in organic chemistry, we write the main product because we have a lot of products which can be produced, but here we mainly write the main product. But the other product here can be water. And now let's go to the oxidation reactions. Oxidation reactions are very important. How are they very important? It's because we can use these reactions to distinguish aldehydes and ketones. We have seen the use of Brady's reagent to distinguish carbonyl compounds from other organic compounds. But this time, it is also possible to distinguish carbonyl compounds themselves, the aldehydes and the ketones. The oxidation reactions, we can use the common strong oxidizing agent. You see the equation here. An aldehyde can react with potassium dichromate in acidic medium to produce an acid. The color changes from orange to green. We will see that when we will be carrying out the practical. You can also use potassium permanganate, where the color will change from purple to colorless. Here it is very important to say that ketones are not easily oxidized. They are not easily oxidized. Aldehydes will give carboxylic acids, but when ketones are oxidized, the chain will be broken to produce two acids. And when we use weak oxidizing agents like ammoniacal silver nitrate and failing solution, the ammoniacal silver nitrate here, it is called Tollens reagent. We get a silver deposit of silver when we are using an aldehyde. But with the ketone, it is not the case. So for a ketone and an aldehyde, you use the silver mirror test. You get a silver deposit. We use Tollens reagent. Here it is a mistake because this happens for the aldehydes. And for the ketones, there is no observable change. So it is for the aldehydes. And for the ketones, there is no oxidation because we said ketones are not easily oxidized. So here there is no oxidation. You use failing solution or Benedict solution, you get a brick red precipitate. Brick red precipitate, and that is copper 1 oxide. We call it copper 1 oxide. But for the ketones, there is no observable change. We will come back to these reactions when we will be carrying out the practicals. Here we have the equations for this oxidation. This is the ions, the complex ions we find in ammoniacal silver nitrate reacting with the aldehyde to produce silver deposit. And here you can see the copper 1 oxide that is produced, the brick red precipitate. We also have the iodoform reaction. The iodoform reaction is very important in which case? We use it to distinguish ketones. Ketones which are said to be methyl ketones, like this one, for example. we have CH3CO, CH2, CH2. So we have a methyl group on one side of the carbonyl group. Because of this, when we treat it with sodium hydroxide and iodine, we produce CHI3, the compound we call iodoform. So we have the reaction here. You have a methyl ketone here. This R can be any alkyl group, but make sure that to get a positive result, you have this methyl group on one side of the carbonyl group. And treated with iodine in the presence of sodium hydroxide, we get this compound, CHI3. This is the compound we call iodoform. And from there, we call the reaction iodoform reaction. Remember, if you have another ketone like this one, CH3CO, CH2, CH3, for this one, you get no observable change. Why? Because you don't have the methyl group here. So we can use this reaction, the iodoform reaction, to distinguish ketones like these ones. And next, we have your homework here. We have discussed a lot how we can distinguish the compounds, the aldehydes and ketones from other organic compounds, aldehydes and ketones as carbonyl compounds, and distinguishing ketones which have different structures. And here, your homework is to question number 1, how can you distinguish propanol and propanone? Number 2, how can you distinguish butanone and butane? Pentane 2-on and pentane 3-on. Here we have a carbonyl compound with another organic compound, aldehyde and ketone and ketone. And question number 2, an organic compound of molecular formula C3H8O was heated with acidified potassium manganate 7 and a compound B was formed. B didn't react with Doran's reagent, but gave a yellow precipitate with Brady's reagent. All these statements have the information you have to use to identify these compounds. The question, identify compounds A and B and write all the equations for the reactions described. Thank you very much for your attention. See you next time.